Okay, so our task is to calculate the size of the tree. We're given a tree. We have to find the number of elements in the tree. So the number of elements is actually the size of the tree. So let's take an example. This is the tree that we're given. As we can see, the tree contains 5 nodes, that is 5 elements. Hence the size of the tree is 5. Let's consider the recursive algorithm from the next slide. Okay, so let's discuss the recursive algorithm to find the size of the tree. This is the function that we're going to use, size. We return the size of the tree, which is an integer, hence the return type int. The node that we pass through the algorithm is the root node, which is the root of the subtree or tree whose size we want to find out. So if root is equal to null, that is this part, we return 0, signifying that the tree is empty. We do this because given the fact that the tree is empty, the size of the tree would be 0, hence we return 0. Else we return size root of left plus size root of right plus 1. So this is the size of the left subtree. This is the size of the right subtree. So the total size is the size of the current element, that is of that particular node, which would be 1, plus the size of the left subtree plus the size of the right subtree. So the right subtree or the left subtree may further contain any number of elements. So this is essentially what we do, the size of the left subtree plus the size of the right subtree plus 1 to signify the current element. Okay, so we talked about the algorithm earlier. Let's explain the algorithm through the example that we initially talked about. This is the tree whose size we want to find out. Okay, so as we can see, this tree has a lot of elements. So let's label each element by a particular pointer. So the node 1 has a pointer n1. We'll use a pointer n2 to signify a pointer to this particular thing. Similarly, n3, n4, and n5. Initially, we want to find out size of n1. So n1 is the root node. We want to find out the size of the tree whose root node is n1. Okay, so this turns out to be size of the left subtree, that is a pointer towards n2, plus size of n3 plus 1. Right, this is not actually n2, this is n1 left, which turns out to be n2. Right, so let's break up n2 further. So this would be size of n4 plus size of n5 plus 1, and this would be 1 plus size of the left subtree and size of the right subtree, which would negate to be 0 because the left and the right pointers would be 0. So, and this particular one over here. So the size of n4 comes out to be 1, and the size of n5 also comes out to be 1. So the total size is 1 into 5, which comes out to be 5.